Before we continue, let me warn you, the next chapter will redefine the phrase, difficult to understand. For my defense, I can say, I genuinely tried to write it in a concise manner. However, the differences between contemporary scientific paradigms and the notions we will propose in this chapter are so vast that arguably, it might demand much effort to understand them. However, there is little I can do to ease this difficulty. All I can say is that I sincerely hope you will understand them. Well, anyway, here goes nothing. At the end of the previous chapter, we described several physical abnormalities, such as non-locality and the random manner by which radioactive decay transpires. This is just a limited selection. Quantum physics introduced many other such abnormalities, to the level it transformed physics into a set of inexplicable mathematical equations. Moreover, many of these equations merely describe the probability, according to which physical events occur. To explain, such equations do not determine if a physical event will occur at a specific time and location, meaning, these equations ignore the specific spatial states which cause these physical events to transpire. Nevertheless, again, experimentation shows these seemingly chaotic physical events, such as the exact location in which a particle would be at an exact time, obey probabilistic equations consistently. Therefore, essentially, these physical events must obey regularities of some sort. Nevertheless, again, because these probabilistic equations do not take into account the specific spatial conditions at which they occur, we can deduce that the regularities governing these events exist independently from the dimension of space. Moreover, because physical motion is an inherent part of the spatial state at which these events transpire, these regularities must exist independently from the dimension of motion as well. Still, because we can measure the effects of these regularities on our world, then obviously, they are relevant to it. Possibly, in the future, as science progresses, we will find methods to predict some of these physical events deterministically. Nevertheless, some of these probabilistic behaviors do not merely reflect our lack of understanding. Arguably, they reflect the physical essence of our world. For example, again, if we consider the exact location in which a particle would be at a specific moment in time, then unless we refute Einstein's theories of relativity, it must remain probabilistic, meaning, we will never be able to predict it deterministically. To summarize, according to empirical findings, it appears our world sustains regularities, somewhat different from the regularities the dimensions of existence, causality, space, motion, and matter sustain. To explain, the physical abnormalities we just mentioned occur within our world, and therefore, according to our metaphysical foundation, the elements responsible for the manner they transpire must be dimensions. Moreover, these dimensions must sustain a metaphysical relation with the elements our world hosts. Nevertheless, again, because these physical abnormalities do not comply with the demands of the dimension of space and the dimension of motion, they cannot be physical elements, meaning they cannot be the dimensions that coil along the three-dimensional flows of causality, of which particles, or photons, consist. In addition, we must remember, these are dimensions. These are existing regularities, which segment the logical field in specific manners. Being as such, they do not change the manner by which they segment the logical field, and therefore, if the regularities they sustain cause each element in our world to behave differently, then the dimensions which affect the different elements in our world must be different as well. Moreover, because these dimensions yield unpredictable physical events, then essentially, none of these dimensions must affect our world. Nevertheless, a specific selection of these dimensions must affect our world. To clarify our last statement, let us consider physical randomness, meaning our inability to determine the exact location in which a particle would be in a specific moment. Again, physical randomness is not the product of our lack of understanding. According to Einstein's theories of relativity, physical randomness is a side effect of the relation between time and space. Therefore, essentially, physical randomness is an inherent feature of our world. Still, again, physical randomness is not chaotic. It is probabilistic. The actual time and place at which we can find a particle obeys a constant probabilistic distribution, consistently. Nevertheless, dimensions are even more demanding. Dimensions do not yield probabilistic behaviors. To explain, if we consider the dimension of existence, it does not permit elements to persist to exist, or come to exist at a specific probability. The regularity it sustains determines that if an element, or alternatively, a dimension, existed before, it must persist to exist. If the dimension of existence permitted probabilistic existence, it would permit the existence of elements which do not need to persist to exist. Therefore, it would host inconsistent elements, and therefore, it could no longer exist within the logical field. Still, again, the fact that physical randomness obeys a probabilistic behavior implies something must regulate it. To clarify, there must be elements which determine the exact location of particles at any specific point in time. Indeed, quantum physics introduced the notion of superpositions, meaning that as long as we do not measure it, a particle exists in all of the possible locations it might be at once. However, as we all know, particles collide with other particles, and the collisions of particles determine the manner by which our world changes discretely. To explain, usually, when a particle collides with another particle, they repel from one another. However, if they do not collide, they proceed along their original trajectory. Therefore, if particles actually existed in several locations at once, it would imply that any collision between two particles could yield two additional copies of themselves. One copy would collide, while the other copy would not, yielding two copies of the original particles, each proceeding along a different trajectory. However, empirically, this does not happen. Therefore, there must be elements which discretely determine the actual location of particles at any point in time. To conclude, even if the dimensions, which determine the location of particles at any specific moment in time, can vary, one specific set of these dimensions must always exist and determine these locations. We will call these dimensions contingent dimensions, as the identity of the regularity they sustain is replaceable. Still, again, the contingency of their identity does not change the fact they are an inherent part of our world. To explain, because these physical abnormalities occur probabilistically, no fixed selection of regularities can determine the manner by which they transpire. Indeed, the dimensional collection we discussed in the previous chapters, meaning the dimensions of existence, causality, space, motion, and matter, is fixed. However, on its own, this dimensional collection cannot yield the world in which we exist. Indeed, in the previous chapter, we refrained from analyzing the dimensional cluster that compiles the dimension of matter, and therefore, arguably, its possible complexity can yield many unexpected behaviors. Still, complex as it might be, this dimensional cluster cannot yield probabilistic behaviors, because as we explained in the previous chapter, it affects our world uniformly. To summarize, again, our world must span two different types of regularities. In the previous chapters, we discussed only one type, meaning the regularities that exist everywhere within our world. We will call the dimensions sustaining these regularities imperative dimensions, as the regularities they sustain are imperative to every element our world hosts. However, contingent dimensions are of a different type. While contingent dimensions affect physical events, again, they do not affect them uniformly throughout the universe. While contingent dimensions determine the spatial location of each particle within our world, each particle within our world can obey the demands of a different set of contingent dimensions. At first glance, the existence of contingent dimensions seems far-fetched. Contemporary science does not speak of such elements. Nevertheless, the effect of contingent dimensions on existing elements within our world is mandatory if we are to compile a consistent metaphysical theory. If contingent dimensions do not exist, it implies physical events occur within our world, without any element determining the manner by which they occur. Therefore, metaphysically, it demands our world is inconsistent. Obviously, we can choose to believe our world is inconsistent. However, considering the levels of consistency, which our knowledge in physics reflects, this seems highly unlikely. Moreover, believing our world is inconsistent is different from believing in a specific religion or anything of the sort. Believing our world is inconsistent implies nothing, as inconsistency cannot yield any type of understanding. Nevertheless, again, as we explained in the introduction chapter, we can choose to believe in whatever we want, as believing does not make it so. It is simply not enough. Still, how can this be? How can our world sustain such two radically different types of regularities? Well, to understand this, we must remember dimensions exist independently from one another. While obviously, the imperative dimensions exist independently from contingent dimensions, apparently, contingent dimensions exist independently from the imperative dimensions as well, as the manner by which they affect our world occurs independently from spatial dispositions. Therefore, we could think that because contingent dimensions do not obey the dimensional complexity our world sustains, they cannot exist in our world. Moreover, obviously, being contingent, the persistent existence of contingent dimensions is not mandatory, and therefore, metaphysically, we could think contingent dimensions are not necessary at all. However, again, our intuitions mislead us. Indeed, contingent dimensions do not obey the demands of the immanent dimensions, and therefore, they are not physical elements our world hosts. Still, the immanent dimensions embody merely a subset of the dimensions compiling our world. The world the immanent dimensions yield can span a possibly infinite collection of worlds, proportionate to the different selections of contingent dimensions that could affect it. Our world embodies merely one such selection. While the selection of contingent dimensions that affect our world is contingent, and therefore, arguably, it can change over time, at any point in time, a specific set of contingent dimensions affect it, deterministically. This conclusion is far from trivial. Science persistently preaches that our world is materialistic, and that essentially, the laws of physics govern our world. However, if our world is indeed consistent, this widespread assumption is simply wrong. The laws of physics cannot account for the role contingent dimensions play, while determining the manner by which physical events transpire. Without contingent dimensions, physical abnormalities, such as physical randomness for example, simply cannot happen, without breaching the consistency of our world. Still, generally, consistent worlds can exist without spanning contingent dimensions. Therefore, for contingent dimensions to affect our world must sustain regularities, or alternatively, dimensions, to support this metaphysical feature. Intuitively, we could think that this could be a dimension our world spans, meaning a dimension that selects the specific sets of contingent dimensions which affect our world. However, this is impossible. Dimensions exist independently from one another, meaning they cannot be aware of anything but themselves, while selecting dimensions explicitly demands the opposite. Still, metaphysically, to affect our world, there must be existing elements, or alternatively, dimensions, that determine the specific sets of contingent dimensions which actually affect it. However, what could these elements be, other than the dimensions our world spans? Well, the answer is right under our noses. In fact, we already introduced these dimensions. In the previous chapter, we suggested that each particle sustains a dimension which coils within the infinite three-dimensional flow of causality, of which it consists. This dimension sets it apart from empty space. Moreover, this dimension is an existing element within the logical field. Naturally, being a dimension, it must exist independently from all other dimensions, including the immanent dimensions. While the dimension of matter determines the trajectory of the three-dimensional flows of causality, of which it consists, as we suggested, on its own, the matter flow is not energetic enough to yield this dimension. Moreover, apparently, the regularities the dimension of matter sustains do not determine these trajectories, but merely allow possibly infinite amount of trajectory variations. Naturally, these variations cannot coexist in space. Each variation yields its own world, which includes its own spatial dispositions. To explain, had these variations coexisted, they would overwrite their mutual spatial dispositions. Therefore, in order to produce a consistent world out of the infinite amount of worldly variations, which the immanent dimensions allow on the quantum levels, the dimensions that coil within each particle select specific behaviors which collectively determine the exact physical state of our world. Each particle spans contingent dimensions from itself and by doing so determines the manner by which our world persists within a small region of space around it. To summarize, metaphysically, there is no real difference between the dimensions our world spans and the dimensions our world hosts. All the dimensions determine the manner by which our world progresses, regardless if they exist universally or as elements the dimension of space hosts. We can rephrase it and say our world does not host dimensions, but rather spans dimensions locally. To summarize, the dimension of space is indeed a hosting dimension, as it allows regularities to coexist independently from one another. Moreover, arguably, its metaphysical function is immanent to all consistent worlds, which host elements within them. To clarify, we should remember the metaphysical function dimensions perform. Dimensions are existing regularities. They divide the logical field into two segments. One segment is consistent with the regularities they sustain, while the other is not. Therefore, metaphysically, a dimension, immanent or contingent, must enhance the dimensional complexity, or alternatively, the regulative complexity, of the segment of the logical field, in which this dimension exists. If it fails to enhance it, it fails to perform any metaphysical function, meaning, it is not a dimension. Still, because according to our metaphysical foundation, only dimensions exist, it would imply, such a dimension, both exists and does not exist, meaning, it is an inconsistent element. To conclude, it appears that the very problem that bothered science, meaning physical randomness, saved us from introducing an unintentional inconsistency into our metaphysical model. To clarify, repeatedly, we differentiated between the dimensions our world spans and the dimensions our world hosts, while in fact, consistent worlds do not support such distinction. While indeed, spatially, contingent dimensions affect merely a small portion of our world, metaphysically, the size of existing elements within our world is insignificant. To explain, indeed, the size of particles, such as atoms for example, appears insignificant in comparison to all the elements we know from our experience. However, as we explained in the previous chapter, just as relative velocities do not exist in our world, metaphysically, the relative size of physical elements within our world is insignificant. Indeed, the replaceable nature of contingent dimensions renders them marginal in our minds. However, we must ask ourselves, contingent to whom? As far as we know, our very consciousness might be the product of contingent dimensions. To explain, because either our consciousness exists, or the illusion of its existence exists, then essentially, according to our metaphysical foundation, dimensions must sustain it. However, sadly, we, meaning humans, die. Therefore, arguably, our consciousnesses are not essential to the existence of the world, and therefore, the dimensions responsible for the existence of our consciousnesses must be contingent. However, naturally, there is nothing we care for more than our very existence, meaning our experience as consciousnesses. Our last conclusions are more than merely not trivial. They fundamentally contradict everything empirical sciences take for granted as they merge the laws of physics with the physical elements they affect. Nevertheless, metaphysically, this is not really a problem. In fact, it is a solution to the problems contemporary physics already encountered. To explain, we already described the connection between contingent dimensions and physical randomness. However, contingent dimensions may be responsible for many other physical abnormalities. For example, if we consider non-locality, then arguably, the reason non-locality exists, meaning the reason we can transmit a signal across space faster than the speed of causality, is because contingent dimensions support it. To explain, as we already mentioned, contingent dimensions exist independently from the web of causality the antimatter flow inflicts. Therefore, as long as it does not physically affect the antimatter flow, beyond the metaphysical scale by which contingent dimension can affect it, several particles may share some type of non-spatial contingent dimensional causality. Moreover, we should remember that metaphysically, passing information faster than the speed of causality is completely different from passing particles through space faster than the speed of causality. Information is analogous to ideas and concepts, and as we already explained in Chapter 1, ideas and concepts are generalizations. They exist only in our minds. They are not existing elements in the logical field. Therefore, metaphysically, passing information faster than the speed of causality does not impose a serious problem, as ontologically, this information does not exist in space. While our minds can decode this information, and therefore, change the manner we behave, in actuality, this information already partially exists in our minds, within the cognitive process by which we decode it. To explain, if we do not know how to decode this information, we can easily fail to understand it or even to recognize it altogether. Moreover, arguably, any existing element within our world, which does not possess the ability to decode this information, would fail to utilize this metaphysical feature, and therefore could not impose any challenge to the speed of causality. Still, this interpretation of the function contingent dimensions play within our world might be wrong. To validate it, we must conduct empirical studies. Nevertheless, even without conducting such studies, metaphysically, by introducing contingent dimensions, non-locality no longer imposes an inexplicable challenge. Still, as we hinted before, contingent dimensions might be responsible for more than arguably meaningless physical abnormalities. As we suggested, metaphysically, our consciousnesses might be the products of contingent dimensions. Moreover, because life both exists and is somewhat contingent, intuitively, we could think contingent dimensions might be responsible for the emergence of life. Still, on their own, these observations do not help us. Essentially, suggesting contingent dimensions are responsible for the emergence of our consciousnesses is no different from determining our consciousnesses are consistent with the logical field. This assumption merely confirms the obvious fact we exist. We did not go through this exhausting path merely to assert what was already obvious to us. We require more meaningful observations, which would tell us more about what makes us tick. Therefore, we must continue to investigate the formation of our consciousness, meaning, we must investigate the manner by which the evolution of life resulted with the emergence of our consciousness. Obviously, this is not an easy task. Methodologically, following the path of evolution imposes a strange explanatory challenge. Unlike the issues we previously discussed, life, evolution, and contingent dimensions do not persist to exist in the same manner as the immanent dimensions. While indeed, life, evolution, and contingent dimensions are widespread, the manner by which they persist to exist is by non-continuous temporal and spatial manifestations. Moreover, as we understood in Chapter 2, according to the physical logic, ontologically, only the present exists, and therefore, arguably, much of the manner by which life, evolution, and contingent dimensions affected our world no longer exists. Even in the present, we can merely predict the probability by which physical events occur, and therefore, obviously, we cannot retrace the reason physical events occurred in the distant past. Therefore, regardless of the role contingent dimensions have played in the formation of life and evolution, we should not expect to find empirical evidence of it. In fact, the same applies to all types of physical evidence dating back long enough. To explain, beyond a certain time frame, the probabilistic manner by which contingent dimensions govern physical events blur the evidence, which would otherwise teach us the manner by which these events occurred. Therefore, essentially, the introduction of contingent dimensions introduces a concept somewhat opposite to the concept the butterfly effect suggests. To explain, while the concept of the butterfly effect suggests an insignificant event happening within the scale of a few particles, compiling the wings of a butterfly can result with physical implications of worldly proportions, the introduction of contingent dimensions suggests the exact opposite. We will name this concept John Doe supernova, or JDS for short. The concept JDS suggests is that events of immense proportions, such as a supernova, for example, could occur in our world without leaving conclusive evidence. With enough time, the entropy contingent dimensions generate, within the antimatter flow, dissolves any single imperative manner, by which we can explain the evidence we find in the present, regardless of spatial magnitudes. In fact, supposing there is a link between the manner by which three-dimensional flows of causality coil within particles, and the metaphysical function of contingent dimensions, then arguably, the particles of which entire galaxies compose might be able to spontaneously transform into either photons, or the antimatter flow, in its raw form. Indeed, such events are highly unlikely, and naturally, we have no record such events ever transpired. Still, metaphysically, it is possible, and therefore, generally, JDS imposes a tough explanatory obstacle when attempting to unveil imminent facts about the manner by which contingent dimensions affected our world. Therefore, without a better option, any discussion regarding contingent dimensions cannot result with imperative conclusions. Even if we have empirical data to support one possible manner by which contingent dimensions affected our world, this evidence must have suffered from the effects of JDS, and therefore, we cannot know if this evidence indeed teaches us how things transpired. Convincing as it might be, the manner by which we interpret such evidence could be incorrect. Moreover, because arguably, the laws that govern the manner by which contingent dimensions affect our world are infinite, the amounts of possible manners by which we can explain the evidence we have is infinite as well. No matter the amount of time and effort we invest, we will never fully document all the possible manners by which contingent dimensions could have affected our world. To conclude, unlike the conventional study of evolution, which attempts to determine the exact manner by which earthly life evolved, we will provide merely one such possible manner. Moreover, we will not bother to validate it, as the evidence that could potentially assert or refute it must have suffered from the effects of JDS, and therefore is not evidence at all. To explain, even if studies in biology would show that the claims we will make are not valid in the present, nothing demands they should be. Contingent dimensions can continuously change the very method by which life persists to exist. While indeed, it is possible that life forms existing in the present carry with them the lessons of evolution, accumulated through millions of years, nothing demands it. In fact, arguably, just as contingent dimensions could possibly decompose galaxies spontaneously, metaphysically, it is possible they could have created every shred of evidence we find on Earth, both spontaneously and instantaneously, at any given moment in time. In many ways, this is the extent of our previous conclusion that only the present exists. While indeed, within contingent worlds, the manner by which events progress from the past into the present and future occur consistently, the introduction of contingent dimensions deems the identity of this past contingent as well. In other words, to the best of our knowledge, the past is replaceable. Moreover, because of the effects of contingent dimensions and JDS, we will prefer accidental explanations for the manner by which evolution progressed over imperative ones. To explain, because the manner by which contingent dimensions affect our world physically is probabilistic, then essentially, all the changes contingent dimensions yield in our world are accidental. They did not have to occur. Obviously, we will not contradict the basic concept behind evolution, meaning survival of the most fitting to survive, or alternatively, natural selection. However, as we already mentioned, it is unlikely yet possible that contingent dimensions created the world as we know it spontaneously, meaning without following any evolutionary process whatsoever. Nevertheless, if we follow this level of argumentative tolerance, we will learn nothing, and therefore nothing will aid us, as we attempt to understand the manner by which our own consciousnesses emerged. Naturally, because the manner by which we will explain evolution will not be imperative, it might be incorrect. However, considering the level of entropy which contingent dimensions introduced into the progress of evolution, every explanation we may ever provide for the formation of evolution might be incorrect as well. Still, what is the connection between contingent dimensions and life? Well, from our experience, we know life exists in our world. Therefore, according to our metaphysical foundation, the existence of life must involve dimensions. However, life cannot be the product of merely the immanent dimensions, meaning the dimensions of existence, causality, space, motion, and matter. But again, why? Well, first, sadly, life forms while the regularities the immanent dimensions sustain, exist eternally. Indeed, as a result of radioactive decay, we can claim that arguably, some particles, or alternatively, dimensions, cease to exist. However, as we already suggested in the previous chapter, the dimensions of which they consist merely change their diameter. The infinity inherent to their internal infinite three-dimensional flows of causality persists. Indeed, arguably, science might come up with a method to convert matter into pure energy, meaning pure into-matter flow, without yielding any smaller particles or photons in the process, and therefore, show that the dimensions of which particles consist, can cease to exist. However, currently, we do not possess such capabilities. Moreover, considering the infinite independent causality each particle encapsulates, then arguably, it is possible that converting particles into pure into-matter flow might require an infinite amount of energy, and therefore, essentially, performing such a task is impossible. Furthermore, because particles do not undergo radioactive decay deterministically, meaning radioactive decay occurs probabilistically, it implies that similar to other types of physical randomness, radioactive decay obeys the regularities contingent dimensions sustain. Moreover, if we consider their exact location at any moment in time, being particles, unstable atoms, prone to radioactive decay, sustain other probabilistic behaviors as well. Therefore, radioactive decay cannot support any argument against the function contingent dimensions play in the formation of life. Indeed, molecules can break down to the atoms of which they consist, and therefore, cease to persist. Nevertheless, as we suggested in the previous chapter, the dimensions that coil within the particles, of which molecules consist, persist to exist. Still, there is a more fundamental reason. The immanent dimensions cannot be the metaphysical entity governing life, because life forms obey the demands of their internal states. Naturally, we could think that man-made machines, such as computers for example, obey the demands of their internal states. However, according to our metaphysical foundation, the internal states of materialistic machines do not exist. But why? Well, the internal state of a materialistic machine is merely a description in our minds of the state of its components. To clarify, supposing we know the manner by which a machine works, by observing it, we can determine its state, according to its abstract design. However, if we simply let a machine operate, the only existing regularities that will govern it, will be the laws of physics, or alternatively, the into-matter flow. Metaphysically, the various states of operations in which we find materialistic machines, are not the regularities that govern the manner by which materialistic machines operate. In other words, these states are not existing regularities, or alternatively, dimensions, and therefore, they cannot exist in the logical field. However, our body is a life form. We feel its existence, and therefore, it must exist in the logical field. Indeed, as we explained in the introduction chapter, we can always argue otherwise. We can argue our body does not exist in the logical field. However, such arguments will not remove the sensation of pain we will feel the next time we bump our Twinkie against a cupboard. Moreover, as we explained so many times before, either our consciousness, or our illusion of harboring a consciousness, must exist. However, when humans die, it is not their consciousness that causes it. It is the body, or alternatively, the life form in which a human consciousness dwells. Therefore, our body must exist, as it enables the existence of our consciousness within this world. Arguably, this statement is problematic, as we deduce it without proof, meaning, it is a product of our choice to believe in a specific metaphysical foundation that supports it. Nevertheless, it is no different from many other conclusions we reached in the previous chapters. Moreover, it does not take a genius to figure out the manner by materialistic machines operate is fundamentally different from the manner by which life forms operate. Life forms strive in chaos for millions of years, while materialistic machines hardly survive 50 years without breaking down. However, such arguments are subjective at best, and therefore, it is best to avoid them. Still, what could be the metaphysical essence of life? Well, in the previous chapter, we explained the formation of particles as the collective product of all the dimensional angles the immanent dimensions impose. Moreover, as we explained, these dimensional angles exist uniformly throughout space. In other words, the dimensional angles, which the immanent dimensions impose, do not change, regardless of local spatial circumstances. Indeed, the dimensional angles the into-matter flow inflicts on particles can change in speed, or through physical interactions with other particles, or photons. However, the regularities that govern the manner by which these dimensional angles will affect a particle are uniform throughout space. For example, if the into-matter flow sustains a local velocity in a specific direction, the into-matter flow will push any particle existing in this section of space in that specific direction. However, life forms behave differently. If a life form needs energy to survive, it will not wait until the into-matter flow would be kind enough to push it toward food. Moreover, if a life form does not require energy, it might decide to harness minerals, such as water, or alternatively, move aimlessly in space. In fact, the antimatter flow might try to push a life form away from its energy source, while the life form would stubbornly fight it. In contrast, the electromagnetic forces, which govern the manner by which molecules compose and decompose, are too general to justify such behaviors. The same applies to all the prime physical forces we know of. To conclude, the metaphysical elements, which govern life forms, cannot be the immanent dimensions, and therefore, without a better metaphysical option, contingent dimensions are the only suitable candidates. Still, how does it actually happen? Well, in order to understand the manner by which contingent dimensions sustain life, metaphysically, we should dive deeper into the internal structure of particles. As we previously concluded, the dimension that coils within a particle segments an area of influence from the logical field over which it sustains its contingent regularities. Because these regularities are contingent, a possibly infinite amount of different contingent dimensional selections can influence this segment. These dimensions span from the dimension that coils within a particle independently both from this dimension as well as from the immanent dimensions. Therefore, essentially, this contingent dimensional cluster embodies an independent contingent world. We will call such worlds Nano Worlds. Indeed, as their name suggests, the volume of space, which Nano Worlds affect, is very small. Nevertheless, potentially, the dimensional complexity of a Nano World can be infinite. Moreover, because arguably, the antimatter flow cannot affect Nano Worlds directly, then from the perspective of a Nano World, its relative small size is insignificant, as within its area of influence only this Nano World exists. Still, even if the antimatter flow cannot affect these Nano Worlds directly, metaphysically, there must be an element, or alternatively, a dimension, that sustains the relation between the internal contingent dimensional state of a particle and the antimatter flow. This dimension bridges the causality between the regularities the immanent dimensions impose with the contingent dimensional regularities of which the Nano Worlds it spans consists. Actually, again, we do not need to find a new dimension to support this metaphysical functionality, as the dimensions that coil within particles already sustain it. To explain, as we previously concluded, the dimension of space serves as a hosting dimension for the areas of influence which the Nano Worlds particles span can affect. While indeed these areas of influence do not adhere to the demands of the antimatter flow, they still fill volumes in space, meaning these areas of influence must be able to host different dimensions and impose regularities within these areas. However, again, these regularities are contingent, and therefore, they do not obey the demands the antimatter flow imposes directly. Instead, these areas respond to the collective demands of both the immanent dimensions and the contingent dimensions that span form particles. These collective demands can vary. Moreover, as we will soon explain, the metaphysical reason why these demands change enable all the physical interactions occurring in our world, including those involving life. Okay, let me now warn you the following paragraphs are possibly the hardest paragraphs to understand in this entire text. Metaphysically, they tie all the loose ends between the immanent dimensions, contingent dimensions, and particles, and therefore, understanding them is of the highest importance. However, to understand them, you must truly understand everything we discussed so far. Therefore, I sincerely suggest you neither skip these paragraphs, nor try to understand them intuitively. However, once you understand them, arguably, you will possess a deeper understanding of physics than most academic scholars. Well, I hope you are ready. We will continue our discussion in T-4, 3, 2, 1. And we are off. Okay, to begin, we should note that the three-dimensional flow of causality, of which a particle consists, fills a volume of space. It travels throughout the entire volume of a particle, and not merely around its surface. Moreover, because the dimension that coils within a particle exists in space, it sustains the same dimensional hosting capabilities as the dimension of space, meaning it spans dimensions locally, throughout its trajectory. It allows contingent dimensions to exist side by side independently. However, because contingent dimensions do not adhere to the demands the dimension of space imposes, the metaphysical identity and function of the contingent dimensions it hosts at any area along its trajectory is replaceable. Essentially, the dimension that coils within a particle can change these spanning locations without affecting the immanent dimensions. Moreover, arguably, because the three-dimensional flow of causality, compiling the trajectory of this dimension, adheres to the demands of the dimension of motion, metaphysically, these dispositions must change. Therefore, essentially, the dimension that coils within a particle can select where to span each contingent dimension it carries spatially along its rotational trajectory. By doing so, it determines which contingent dimensions span on its surface and establish a metaphysical relation with the antimatter flow. Moreover, metaphysically, each such spatial disposition imposes different relations between the contingent dimensions, spanning form the dimension that coils within a particle, which in turn determine the next spatial distribution of contingent dimensions along its trajectory. In other words, the dimension that coils within a particle serves as a shifting contingent dimensional matrix of causality. In simpler terms, the dimension that coils within a particle can sustain different stateful relations between the antimatter flow and the contingent dimensions that span from it. In short, it allows particles to behave in a stateful manner, and therefore, metaphysically, it serves as the enabler of life. Still, what does it mean? How can contingent dimensions sustain a metaphysical relation with the antimatter flow? Have we not repeatedly argued dimensions must exist independently from one another? How can contingent dimensions interact with dimensions other than themselves? Well, that is exactly the point. The contingent dimensions spanning from particles interact merely with occurrences of themselves. To explain, the contingent dimensions that span from particles interact with occurrences of themselves, which they meet along the antimatter flow, as well as the three-dimensional flows of causality, of which particles consist. But how? Have we not explicitly explained that only particles span nano worlds? Well, we have, but we did so only for simplification. To explain, contingent dimensions exist independently from the immanent dimensions, and therefore nothing forbids them from appearing anywhere in our world. However, without particles, they merely move in empty space, along the antimatter flow. Potentially, these contingent dimensions could affect elements, or alternatively, dimensions. However, as we explained in the previous chapter, the antimatter flow is a single element, and therefore, without particles, the contingent dimensions the antimatter flow carries have no elements to affect. Their existence remains meaningless until they meet a particle floating in space. These particles may span similar contingent dimensions, and therefore, the contingent dimensions traveling along the antimatter flow are relevant to them. However, as we explained in the previous chapter, the azimuth of the local velocity at which contingent dimensions travel in empty space can be different from the azimuth the same contingent dimensions travel along the three-dimensional flow of causality of which a particle consists. Therefore, essentially, these contingent dimensions can collide with one another. To explain, these contingent dimensions are no different from the dimensions that coil within particles, meaning they span locally in space. Still, because the dimension that coils within a particle is an independent and integral metaphysical element, the effects of such collisions reverberate through it in the same manner collisions between particles reverberate in empty space. To explain, the dimension that coils within a particle shares the same properties as the dimension of space, with the little difference that spatially, the infinite space it encapsulates endlessly rotates around a central pivot. Collisions occur within it, similarly to the manner they occur in space, with the small difference that the trajectories by which three-dimensional flows of causality progress within it are more curved than they are in empty space. Nevertheless, collisions within this dimension cause the same causality propagations as those appearing in empty space. If the contingent dimensions it hosts collide, they are pushed against other contingent dimensions, in a manner similar to the manner particles push particles in space. Still, this motion of contingent dimensions along it obeys the same regularity of motion empty space obeys. It follows the same restriction, meaning the constant speed of causality. The same process applies to all the contingent dimensions that span from a particle. In short, this is the reason why the antimatter flow can affect particles in the first place. To explain, the dimension that coils within a particle exists independently from all other dimensions. Therefore, it cannot be aware of any other dimensions, including the immanent dimensions. Still, because it coils contingent dimensions along its trajectory, these contingent dimensions can affect its location in space. In other words, the contingent dimensions it carries push it in the direction of its local velocity, and not the immanent dimensions. To clarify, as we explained in the previous chapter, velocity is local, and therefore it can only affect local metaphysical elements, such as contingent dimensions. In short, while the antimatter flow propels our world, contingent dimensions are the metaphysical elements, which actually do the lifting. They are the metaphysical entity which yields the necessary friction between particles and the antimatter flow. Moreover, arguably, if a particle can refrain from spanning the contingent dimensions the antimatter flow directs at it, it can remain oblivious to the antimatter flow, meaning it can remain indifferent to forces such as gravity and perhaps electromagnetism. Still, this is only a hypothesis. It just might be that because the antimatter flow is a single metaphysical element, it spans all the contingent dimensions that exist in our world simultaneously, and therefore, regardless which contingent dimensions a particle spans, the antimatter flow must affect it. Okay, now that we have crossed this enigmatic section, let us return to our previous course of discussion, meaning the stateful relations particles sustain between the antimatter flow and contingent dimensions. Considering our conclusions, just as with all the dimensions we discussed previously, we should address the dimension that coils within a particle, according to its metaphysical function, and not merely according to its spatial manifestations. Therefore, let us rename this dimension. From now on, we will call this dimension, the dimension of life. While we could think that because each particle spans the dimension of life separately, the dimension of life is not a single dimension, but rather a collection of dimensions, as large as the amount of particles in our universe. To clarify, again, according to contemporary physics, all particles exhibit physical randomness, and therefore, each particle should sustain its own dimension of life. However, this is only partially true. To explain, according to our previous conclusions, our world does not really host dimensions in space, but rather, spans worlds side by side. Each of these worlds spans its own set of dimensions, which includes the dimension of life. Moreover, because according to contemporary physics, all particles exhibit probabilistic behaviors, the metaphysical function of each copy of the dimension of life is uniform. To conclude, the dimension of life is no different from any other immanent dimension, and therefore, essentially, it is an immanent dimension. In fact, arguably, without the dimension of life, the areas of influence particles affect would have become inconsistent elements, meaning particles could no longer exist in the logical field. The regularity the dimension of life sustains transforms each particle within our world into a natural yet powerful consistent state transition machine. At each moment, the contingent dimensions composing the nano world a particle spans determine both the manner by which the particle reacts to its current external conditions, or alternatively, the antimatter flow, as well as change the segment within the dimension of life, which would react to future external conditions. Computer sciences have already described such state transition apparatuses. To be more specific, in computer science's terminology, each particle sustains a deterministic infinite automaton. To explain, in computer sciences, a deterministic automaton is an abstract deterministic description of the manner by which a memoryless machine changes its state with respect to incoming data. At each state, a deterministic automaton defines a set of fixed conditions which determine what inputs would cause it to shift into what next states. In turn, potentially, each state a deterministic automaton defines could serve to fulfill a desired function. Indeed, due to materialistic limitations, computer sciences mainly discuss deterministic finite automatons. Still, deterministic finite automatons are more than just computational models appearing in forgotten books of the computer sciences faculty. In fact, all of the machines we know consist of a collection of interacting deterministic finite automatons. For example, if we consider a candy machine, it embodies a simple deterministic finite automaton. A simple candy machine has three states which define the manner we can extract candies by interacting with it. To clarify, let us review these states. 1. The candy machine has candies within it, but we did not insert a coin into it yet. If we pull the Get Candy lever, nothing happens. If we push the Return Money button, nothing happens. If we insert a coin, the candy machine shifts to the next state. 2. The candy machine has candies within it, and the coin we previously inserted into it. If we push the Return Money button, the candy machine would eject the coin we inserted and return to the previous state. If we try to insert an additional coin, the candy machine would reject it. If we pull the Get Candy lever, the candy machine would eject a candy. Now, if the candy machine has additional candies within it, it will return to the previous state. If not, it will proceed to the next state. 3. The candy machine has no candies within it. Until we fill it with more candies, the candy machine will remain in this state, regardless if we insert a coin to it, pull its Get Candy lever, or push the Return Money button. We can find similar more complex automatons within the architecture of contemporary computers. While indeed, contemporary computers store data in memory, essentially, the manner by which contemporary computers implement their ability to store data in memory breaks down to several complex deterministic finite automatons, which utilize electromagnetic properties of matter. Still, complex as contemporary computers might be, potentially, the complexity of the deterministic automatons particles obey can be infinite. Potentially, the dimension of life that spans within a particle can harbor both an infinite amount of states and an infinite amount of contingent dimensions, which define the manner by which these states change. However, because man-made machines depend on materialistic manifestations of particles and not dimensional complexity, essentially, the complexity of materialistic man-made machines would forever be finite. To explain, a materialistic man-made machine depends on the amount of different states the particles of which it consists can sustain discretely, while contingent dimensional apparatuses are not bound by such limitations. However, contrary to man-made materialistic machines, essentially, nothing designs these natural deterministic infinite automatons. The deterministic infinite automatons particles obey are the product of their metaphysical essence and not of any inclination to sustain a useful functionality. Therefore, even though these deterministic automatons can be infinitely more complex and versatile than man-made materialistic machines, essentially, the behaviors these contingent dimensional apparatuses inflict are mostly chaotic. Nevertheless, contrary to the traditional belief the science of biology endorses, these contingent dimensional apparatuses are the building blocks of life and not chemical or physical reactions. To clarify, as we explained in the previous chapter, the immanent dimensions, or alternatively, the antimatter flow, are responsible for both chemical and physical reactions, and therefore, cannot allow any type of behavior, dependent on the internal state of a life form. Nevertheless, obviously, to yield complex life forms, contingent dimensional apparatuses must manipulate the antimatter flow. To explain, in many ways, contingent dimensional apparatuses are analogous to drivers, navigating materialistic chemical and physical machines, quite like we drive materialistic cars, which utilize chemicals such as gasoline for fuel. To summarize, life is not rare. In fact, arguably, all particles are alive. While from our perspective, the physical behaviors particles exhibit appear chaotic, in actuality, we simply do not understand what they are trying to do. Moreover, because the potential dimensional complexity of nano worlds is infinite, the variety of behaviors particles exhibit is too large to diagnose or categorize in full. Moreover, because the scale of particles is so small, it is very hard for us to analyze these behaviors. Nevertheless, obviously, as we just mentioned, life appears in more distinguishable forms as well, in terms of spatial scale, availability, and persistence. In fact, in many ways, the three are interlinked. To explain, for us to distinguish a specific life form, implicitly, it demands we can generalize its physical manifestations. Such a life form must exhibit specific repeated behavioral patterns. Alternatively, the automatons that govern such life forms must continuously return to a specific set of states, from which they undergo repeated similar state transitions. Still, even if a particle repeats the same state transitions, if a contingent dimensional automaton manipulates merely one particle, we cannot distinguish it. To explain, the states and state transitions we previously discussed involve relations between particles and the antimatter flow. However, because the internal states particles sustain consist of contingent dimensions, we cannot observe them. These contingent dimensions are local, meaning they are relevant only within the area of influence the particle affects. Moreover, as we already mentioned, we cannot know the exact location of a particle at any point in time. In addition, we cannot distinguish the external state to which the particle reacts. If the particle reacts to pure antimatter flow, it implies the particle reacts to empty space, and therefore, obviously, there is nothing for us to observe. Still, because physical randomness makes it impossible for us to determine the location of particles, even if a particle reacts to nearby particles, we cannot determine what external dispositions these nearby particles imposed on it. To conclude, while arguably, all particles sustain the miracle of life, to be able to either distinguish or discuss life forms, they must consist of several particles. Therefore, to ease our future discussion, we will call such distinguishable life forms complexitons. Complexitons are life forms consisting of several particles. Furthermore, we will call the particles of which complexitons consist nano-organs. For us to distinguish complexitons, they must obey several demands. First, similarly to life forms consisting of single particles, there must be a distinguishable set of spatial state transitions, which the nano-organs of complexitons must repeat. If such a set does not exist, we would have no way of recognizing the behavioral integrity of a complexiton. However, unlike life forms consisting of single particles, the states and state transitions complexitons sustain must obey the regularities which both contingent and immanent dimensions impose. To explain, as we already mentioned, contingent dimensions can merely affect the area of influence of a particle, or alternatively, a nano-organ. However, the areas of influence which complexitons affect is larger, as it includes both the area of influence of each of their nano-organs as well as the empty area that stretches between them. However, because the area between the nano-organs of a complexiton lies outside the area of influence of each of its nano-organs, only the antimatter flow can determine the manner by which physical events transpire within these areas. Therefore, the repeated behaviors which complexitons exhibit must include repeated similar spatial kinetic changes which occur between its nano-organs. Therefore, the automaton a complexiton obeys should include state transition feedbacks between its nano-organs. To explain, as one of the nano-organs of a complexiton shifts its internal state, it affects neighboring nano-organs through the antimatter flow. In other words, it changes their external states. In turn, these neighboring nano-organs change their internal state, and continue to propagate changes throughout the complexiton, including changing the external state of the nano-organ, which originally affected them. Still, obviously, being a complexiton, to persist to exist, it must continue to consist of several nano-organs. If it fails to consist of several nano-organs, it implies it consists of merely one particle, and therefore, as we already concluded, we would not be able to distinguish it. Therefore, to prevent the disintegration of complexitons, the causality propagations between the nano-organs of a complexiton must sustain a kinetic equilibrium. The feedback between the nano-organs of a complexiton should not allow these nano-organs to shift into states which would breach the kinetic integrity of the complexiton to which they belong. Considering this, we should not expect to find nano-organs consisting of single atoms. To explain, as we just mentioned, for us to distinguish the existence of a complexiton, spatially, it must exhibit repeated kinetic behaviors or alternatively, a kinetic equilibrium. In other words, nano-organs must move within it in a repeated similar fashion. However, as we explained in the previous chapter, as particles move in space, they can merge with additional particles and form molecules. In fact, experimentation shows that generally, single atoms, with the possible exception of crystals, have a tendency to merge into molecules. However, once particles merge into molecules, they no longer exhibit any distinguishable motion, as the motion they exhibit is limited to the internal motion occurring within the molecule in which they exist. In other words, for us to distinguish a complexiton, the molecules of which it consists must exhibit spatial motion, as essentially, these molecules are its nano-organs and not the atoms that compile them. Indeed, single atoms are crucial for the existence of earthly life forms. For example, oxygen is crucial for the existence of most, if not all, earthly life forms. However, complexitons mostly refrain from utilizing single atoms, such as oxygen for example, as their nano-organs. To explain, if complexitons utilized single atoms as their nano-organs, they would constantly be at the risk. Their nano-organs would merge with external particles and no longer fulfill the function the complexiton assigned to them. Therefore, instead, we should expect to find complex molecules within complexitons, as relatively, such molecules are resistant to both disintegration into the particles of which they consist and absorption of external particles. Naturally, complexitons can reassemble and disassemble these molecules. In fact, according to empirical research, complexitons conserve and utilize such molecular compositions and decompositions to store and utilize energy. Still, these molecular compositions and decompositions hardly occur spontaneously in nature. In fact, arguably, without a complex contingent dimensional apparatus, or a man-made laboratory, they might not occur at all. Nevertheless, it is important to understand the limitations we just mentioned regarding the materials complexitons utilize is not a general limitation, which all complexitons must obey. It is merely a limitation of our ability to recognize and distinguish complexitons. To put it in context, as we already explained, essentially, all particles are life forms. Particles may sustain kinetic equilibriums similar to those distinguishable complexitons sustain, without us recognizing it. Moreover, it is not as if complexitons want to sustain kinetic equilibriums. The emergence of such kinetic equilibriums occurred by chance. In many ways, these kinetic equilibriums do not reflect an inclination to sustain a complexiton, but rather, a metaphysical accident, which caused particles to get stuck in an endless distinguishable motion. In fact, this reflects in the manner by which life forms sustain their kinetic equilibriums. To explain, intuitively, we could think that because complexitons want to live, they sustain stable kinetic equilibriums in which none of their nano-organs leave them. However, experimentation in biology clearly shows that life forms repeatedly replace the particles of which they consist. Moreover, if we consider the possibly infinite dimensional complexity of nano worlds, the chances of reaching such a stable equilibrium, in which a nano-organ never exits a specific set of contingent dimensional states, are very slim. In fact, had complexitons sustained such perfect equilibriums, then arguably, they would never die. To explain, particles always sustain a contingent dimensional automaton, and therefore, essentially, life never truly dies. Therefore, if the nano-organs of a complexiton never reach a state outside the kinetic equilibrium which the automaton this complexiton sustains, then essentially, nothing could cause it to stop functioning as a whole. However, again, this is highly unlikely. At any moment, a stream of particles could slice a complexiton in two, interrupting the kinetic equilibrium it sustains. To conclude, apparently, the kinetic equilibriums complexitons exhibit should be a result of a different process. Still, what could this process be? Well, to understand this process, we should revisit our conclusions from the previous chapter regarding the three-dimensional flows of causality of which particles consist, or alternatively, the dimension of life. To be more specific, we should consider our assumptions regarding electromagnetism. As we suggested, particles can emit and absorb lumps of three-dimensional flows of causality in the form of electrons. Still, metaphysically, these lumps of three-dimensional flows of causality originate from the same dimension of life the particle they left sustains. Therefore, they span the same nano-world as the particle they left. Indeed, spatially, these lumps filled only a small segment of the particle they left. However, because nano-worlds consist of contingent dimensions, all of these dimensions exist independently from the immanent dimensions, and therefore, the spatial volume they fill is irrelevant to their metaphysical essence. In short, by emitting and absorbing these three-dimensional lumps of causality, particles can share nano-worlds. To explain, essentially, the electrons leaving a particle serve as contingent dimensional messengers. Actually, photons might be capable of performing a similar metaphysical function. However, as of yet, it is unclear whether photons actually span dimensions of life, and therefore, it is unclear whether they can carry nano-worlds along their trajectory. Still, regardless, once a particle absorbs an electron, or possibly a photon, it also assimilates the nano-world this contingent dimensional messenger spans into the nano-world it already spans. Obviously, some of the contingent dimensions of both the particle and the electron it absorbed may produce metaphysical inconsistencies, and therefore, fail to yield any specific function. However, some of the contingent dimensions the incoming electron spans do not contradict the nano-world the absorbing particle spans, and therefore, after such a contingent dimensional transmission, the absorbing particle would begin to exhibit behaviors similar to those the original particle exhibits. This applies even more to nano-organs. Unlike external incoming particles, the nano-organs of a complexiton repeatedly share electrons. Moreover, if this process involves photons, the physical proximity between nano-organs increases the probability neighboring nano-organs would intercept these photons and assimilate whatever contingent dimensions they carry. Therefore, metaphysically, the nano-worlds they span must merge continuously, and therefore, essentially, the nano-worlds they span are very similar, if not identical. In fact, this in itself increases the robustness of the automatons such complexitons sustain. To explain, just as a nano-organ can emit electrons or photons and assimilate incoming particles, it can absorb electrons and photons from external particles. These external electrons endanger the integrity of the nano-world these nano-organs span, and therefore, risk the integrity of the kinetic equilibrium the complexiton sustains. Still, because all the other nano-organs of a complexiton share electrons repeatedly, they provide a correcting contingent dimensional feedback, as they reprogram this infected nano-organ with the automaton they sustain. Nevertheless, this comes with a price. Because of this correcting contingent dimensional feedback, essentially, all the nano-worlds that span from the nano-organs of a complexiton are either similar or identical. Therefore, this process imposes a complexity limitation over the automaton such complexitons sustain, at least as far as these primitive complexitons are concerned. Our last conclusions raise a question regarding the biological function our DNA fulfills. Traditionally, the science of biology endorses the idea that DNA molecules encapsulate the instructions life forms obey. Moreover, biology dictates that the size of DNA molecules, meaning the amount of particles of which they consist, is proportionate with the biological complexity of the life form that harbors them. However, according to our previous conclusions, this widespread belief is inexact, if not completely wrong. To explain, according to our previous conclusions, neither the immanent dimensions, nor the physical structure nano-organs formalize, determine the behavioral complexity complexitons exhibit. The behavioral complexity complexitons exhibit derive from the internal contingent dimensional automaton their nano-organs sustain. In other words, complexitons have no problem exhibiting complex behaviors, regardless of the amount of nano-organs they manipulate. In fact, the problems complexitons face are exactly the opposite. To explain, the possible contingent dimensional infinity that defines the automatons their nano-organs obey renders it difficult for complexitons to sustain any type of repeated behavioral patterns. To clarify, in most cases, these behaviors are too complex for us to distinguish. Nevertheless, again, this complexity is not the product of a lack of behavioral complexity, or non-deterministic chaotic behavior. It is the product of a possibly infinitely complex deterministic contingent dimensional automaton. Therefore, there can be no direct connection between the size of DNA molecules and the behavioral complexity complexitons exhibit, as potentially, complexitons exhibit infinitely complex behaviors by default. Moreover, because our DNA is a molecule, it shares its nano-world with all the particles of which it consists. In other words, all the particles of which DNA molecules consist must sustain the same automaton. Moreover, as we just explained, arguably, all the nano-organs of a complexiton sustain this automaton as well. Nevertheless, empirical research in the field of genetics clearly shows a link between specific segments of our DNA and specific behaviors life forms exhibit. Therefore, obviously, there must be such a link. However, as we previously hinted, this link is indirect. To explain, as we just mentioned, potentially, the behavioral complexity nano worlds impose is infinite. This infinity imposes a problem for complexitons to sustain kinetic equilibriums or alternatively, to persist to exist as complexitons. To sustain kinetic equilibriums, complexitons must be able to isolate discrete behaviors when necessary. If they did not, then arguably, they could not exist, and therefore, we would have no records they ever existed. Therefore, complexitons require a method to determine the specific behavior they perform. However, the contingent dimensional automaton they sustain is static. To explain, it is merely a collection of dimensions, or alternatively, a definition in our minds. In other words, it does not exist in the logical field, and therefore, obviously, within the logical field, it cannot change. Still, the behaviors this nano-world determines depend on the external conditions to which it reacts. To explain, this nano-world determines fixed behaviors to fixed external conditions. Therefore, by determining specific external conditions, complexitons can extract specific behaviors from these nano-worlds. And this is exactly the function DNA molecules provide. By storing fixed sets of particles, DNA molecules can inflict fixed sets of external conditions on the nano-worlds they harbor, which in turn results with specific behaviors. In other words, DNA molecules serve as an indexing system, by which complexitons can extract specific behaviors at will. Still, these behaviors are not the product of the physical structure of DNA molecules, but rather of the external changes they inflict on the nano-world's complexitons span. Therefore, arguably, it is possible that the same indexing system would yield different behaviors in different complexitons, as the nano-world each complexiton spans can be fundamentally different. Nevertheless, there is no way to determine this, because again, contingent dimensions are both local and independent of the immanent dimensions, and therefore the contingent dimensional composition of particles cannot be assessed through the immanent dimensions. At best, we can assess the contingent dimensions of which our consciousness consists. However, again, we have not yet provided a metaphysical explanation for the formation of our consciousness, and therefore, we should delay this discussion. Still, regardless of the biological role of DNA molecules, arguably, we have provided a feasible model for the emergence of complexitons. Complexitons utilize contingent dimensional transmissions to retain their biological integrity. Moreover, these contingent dimensional transmissions yield a primitive reproduction mechanism. As new particles approach the life form, they absorb electrons from the complexiton, and therefore, absorb the nano-world that governs them, or alternatively, the automaton the complexiton obeys. In other words, the complexiton reproduces itself onto incoming particles. Moreover, because as we already explained, a complexiton must manipulate both contingent and immanent dimensions, then essentially, during this process, the complexiton can control both the internal and external states of incoming particles. Therefore, as new particles approach a complexiton, they absorb both their external states, meaning the external conditions which the antimatter flow imposes, and the manner by which they will change their state, meaning the internal contingent dimensional nano-world which governs the complexiton. Therefore, unlike the nano-organs of which the complexiton already consisted, which might have already strayed away from life-sustaining states, such incoming particles are both compliant with the automaton of which the complexiton consists, as well as more predictable in terms of states and state transitions. Therefore, by replacing older particles with these new incoming particles, complexitons can sustain a relatively robust kinetic equilibrium, even without obeying a perfect automaton. To explain, each time a nano-organ goes out of sync from the function it serves within the complexiton, new, synchronized, nano-organs replace it. Indeed, the chances for such an automaton to appear without anything designing it are slim. Nevertheless, they are infinitely higher than the chances a perfect automaton emerged out of thin air. Unlike perfect automatons, such particle-replacing automatons need not cope with an infinite amount of both internal and external states. Instead, they can suffice with only a limited selection of such states. Nevertheless, even if complexitons find it safer to replace older nano-organs with newer ones, it does not imply that the older nano-organs are necessarily defected. Therefore, as such complexitons decommission and emit their older nano-organs, these nano-organs may be able to continue their contingent dimensional functionality, and form new similar complexitons. Therefore, essentially, this process ensures both the robustness of the existence of such complexitons, as well as allows their reproduction. Still, again, the chances for such an evolutionary process to transpire are very slim, because it emerged by chance and not by design. As these complexitons first emerged, their kinetic equilibriums were anything but robust. This evolutionary process was coincidental, and therefore, naturally, when it first appeared it was not perfectly designed. Metaphorically, the manner by which these complexitons moved their nano-organs in space was confused. They were not designed to resist strong gravitational forces, or to withstand harsh physical conditions, such as particles zooming toward them or photons colliding with them energetically. Therefore, of all the earthly locations in which they could evolve, our Earth's oceans were the most ideal. The oceans, and the Earth's atmosphere above it, protected these primitive complexitons from energetic radiation originating from outer space. In addition, the liquid environment, which surrounded these primitive complexitons, provided them with an abundance of new particles to absorb and emit. To explain, while in dry land, particles exist mainly on the ground, in a liquid, they exist in all spatial directions. Moreover, arguably, because these primitive complexitons could float within this environment, in all spatial directions, their kinetic equilibriums faced less spatial restrictions than they faced on dry land. To explain, on dry land, complexitons require more energy to move. The complexiton must elevate itself above the ground, and therefore, it demands the complexiton insists to move. However, these primitive complexitons were probably so different from life as we know it, that discussing them in terms of elevation from the ground is presumptuous at best. The truth is, primitive complexitons could have appeared on the dry surface of the Earth as well, or within solids. Moreover, arguably, crystals may embody such life forms, as the manner by which they grow in nature somewhat resembles the function of a complexiton. In fact, because all particles sustain automatons, then arguably, complexitons can just as well appear in gas clouds hovering in empty space. Arguably, as long as such clouds are protected from highly energetic radiation, the zero gravitational conditions existing in such gas clouds might provide an even better breeding ground for complexitons than water. In fact, empirical data support this hypothesis. According to empirical study, salmonella bacteria strive in space, and some earthly bacteria can survive in the vacuum of space for up to a month. Still, regardless, considering the chemical composition of the particles in which complexitons can emerge, arguably, any other liquids and atmospheres could have sufficed. To explain, indeed, life on Earth requires water to exist. However, this does not imply water is a necessary ingredient for life. As we already explained, to exist, life merely requires the existence of particles. Therefore, arguably, the only reason earthly life forms require water to exist is because they all carry the same genetic inheritance of their origins, meaning the manner by which complexitons came to exist in Earth's oceans. Therefore, it would not be surprising if we would find complexitons on other planets which do not have water. Moreover, possibly, we could find complexitons on other planets in which there are no liquids whatsoever. Obviously, these complexitons will be radically different from life on Earth. Still, they would be alive, just as we are. So far, we have merely discussed the feasibility and distinguishability of the emergence of complexitons. However, obviously, the evolution of life did not end there. While complexitons continue to follow the general principles we already described, meaning, refreshing their nano-organs with new particles, the manner by which complexitons realized this principle changed their level of self-sustainability. For example, the spatial location within the complexiton, in which the complexiton absorbed newly arriving particles, had dramatic evolutionary implications. Naturally, the most trivial location in which complexitons could assimilate inbound particles was their outskirts, as this was the first location at which these primitive complexitons established physical contact with fresh inbound particles. However, assimilating particles in the outskirts of complexitons is problematic. To explain, just as a complexiton can span its automaton on inbound particles can hijack the nano-organs of a complexiton by spanning their own nano worlds from the nano-organs located in the outskirts of the complexiton. Moreover, because as we just explained, complexitons need to continuously replace the particles of which their nano-organs consist, they require a steady supply of new inbound particles. Therefore, if such primitive complexitons assigned only one of their edges as the location in which they assimilated new particles, then once inbound particles hijacked its nano-organs along this edge, they terminated this supply line. In response, the automaton that governed such a complexiton went out of sync and breached the kinetic equilibrium the complexiton previously sustained. In other words, it could have killed such a complexiton. Therefore, for more robust complexitons to emerge, these complexitons should have harvested inbound particles arriving from all spatial directions. Still, this raises a new problem. Indeed, by assimilating particles arriving from all directions, these primitive complexitons could have ensured a more stable supply of inbound particles. However, when inbound particles hijack the nano-organs of a complexiton, it does not imply these nano-organs leave the complexiton. Such hijacked nano-organs simply sustain a different automaton. Indeed, as we already discussed, other nano-organs can provide a correcting contingent dimensional feedback, and resurrect the automaton these hijacked nano-organs sustain. However, if a complexiton assigned all of its nano-organs on its outskirts to assimilate new particles, it risked the possibility that the nano-organs all around its outskirts would fail to span the automaton that governed this complexiton. Therefore, such a complexiton could have easily lost its functional integrity and die. The problems we just mentioned are severe. In fact, arguably, such complexitons could not survive. The possibly infinite variety of nano worlds each such complexiton could absorb deems it close to impossible to sustain a self-sustaining automaton. Indeed, such complexitons reproduce themselves, and therefore, theoretically, they could flourish. Still, even if they could reproduce, the nano worlds they inherited to their offspring suffered the same defects as their parents, meaning an automaton that fails to establish a kinetic equilibrium. In short, for complexitons to flourish, they must have adopted a different type of behavior. In fact, this behavior could have initiated the mutation of life on Earth into the shape in which we know it today, meaning cellular life. Actually, this behavior is quite trivial, and arguably, it might not have required many years of evolution to attain it. To explain, as we previously mentioned, to sustain robust kinetic equilibriums, complexitons continuously replaced the particles of which their nano-organs consisted with fresh synchronized nano-organs. Indeed, the most obvious place to find new particles was the outskirts of these complexitons, as this was the spatial location at which these complexitons established first contact with inbound particles. However, replacing particles implies the complexiton must emit older particles as well. But in what manner? Previously, we disregarded this issue. We merely suggested that a complexiton can sustain a kinetic equilibrium by repeatedly replacing the particles of which its nano-organs consist with newer particles. Still, as we already suggested, the nano-world governing the automaton a complexiton obeys exists as a similar copy in all of its nano-organs. Therefore, without a more advanced automaton, meaning an automaton that assigns different functions to different nano-organs, all its nano-organs should have performed the same functionality. In other words, if these complexitons replaced their particles, it suggests all their nano-organs performed such particle replacements. Therefore, it suggests all the nano-organs of which these primitive complexitons consisted continuously replaced their older particles with newer ones, while emitting older nano-organs and overall generating a cloud consisting of the nano-organs they emitted. Still, we should remember the general principle that governed this evolutionary process. There was no element consciously designing it. This evolutionary process occurred by chance and persisted to exist simply because it was self-sustaining. Therefore, it is highly unlikely the regularities that governed it were any more precise than the minimal level of precision that was self-sustainable. Therefore, it is most likely these primitive complexitons did not test the integrity of the automatons that each of their nano-organs spanned. In other words, as we previously speculated, most of the nano-organs these primitive complexitons emitted should have still obeyed the correct automaton. Therefore, even though the complexiton already disposed of these nano-organs, they could still yield a correcting contingent dimensional feedback towards neighboring particles. This behavior increased the contingent dimensional integrity and similarity between the nano-organs of a complexiton. The closer particles were to the center of these clouds, the higher was the similarity between the automaton they obeyed and the original automaton that governed these complexitons. In short, this behavior increased the survival potential of these complexitons, and therefore, increased their evolutionary successfulness. Generally, this behavior increased the biological similarities between these ancient earthly life forms and contemporary earthly life forms. Unlike the somewhat abstractly shaped complexitons we previously discussed, such particle clouds filled volumes of space with particles that obeyed a single integral agenda. Moreover, such primitive complexitons exhibited principles similar to those contemporary life forms exhibit, in the sense that they protected their most crucial areas, meaning the areas in which they reproduced, by more disposable layers of particles, in the same manner a body shields an animal's internal organs with either skin, muscles, bones, or limbs, which extend further away from the center of the body, while essentially, they are not imperative for the persistent existence of the life form. Nevertheless, these primitive complexitons were not cellular. To clarify, the clouds of particles we previously mentioned were not bound by any type of membranes in the same manner as living cells. Potentially, these clouds could have extended endlessly, wherever they could handle the external conditions in which these primitive complexitons dwelled. Still, the persistent existence of such complexitons was not robust. To explain, other complexitons could have developed a contingent dimensional automaton, which could resist assimilation into these clouds, while at the same time nurturing a cloud of their own at the original cloud's expense. In fact, metaphysically, achieving this is not that difficult. To explain, while indeed the automaton the particle sustains demands specific changes must occur in specific states. As we previously explained, these states consist of two components, internal and external. The external states are a product of the antimatter flow, and therefore, complexitons cannot fully alter or manipulate them. However, a nano world can determine that specific internal contingent dimensional states are unreachable, such as the internal states which sustain the kinetic equilibrium of the assimilating complexiton. Such a resistant complexiton utilizes the infinity of the dimension of life to host external nano worlds it encounters within unreachable segments of the dimension of life. Such a resistant complexiton sustains its own kinetic equilibrium, which ensures it does not reach this segment of the dimension of life, and therefore, essentially, when it absorbs such nano worlds, it does not affect its behavior. Nevertheless, this type of contingent dimensional protection is not foolproof. To explain, just as the nano-organs of a complexiton can remain indifferent to the automaton another complexiton obeys, other complexitons could have returned the favor by assimilating its nano-organs while remaining indifferent to the automaton it obeyed. In short, this type of behavior initiated an endless competition between complexitons. Essentially, all of these complexitons utilize the same type of protection, meaning different segmentations of the dimension of life. However, again, these segmentations were dependent on two factors, internal and external, and therefore, the external conditions the antimatter flow inflicted on these complexitons could have easily shifted their nano-organs into newer segmentations. Such a disposition was prone to change, as soon as complexitons revised a different behavior, by which they retained their functional integrity. Under such circumstances, obviously, any complexiton, which could surround itself with some sort of filtering barrier, had an evolutionary advantage. A filtering barrier, or alternatively, membrane, could help ensure external complexitons could no longer hijack nano-organs from it. On the one hand, such a membrane could diffuse some of the contingent dimensions external complexitons span, and therefore, reduce the risk of infecting its nano-organs with the automaton of another complexiton. On the other hand, even if an external complexiton managed to infect the nano-organs of a complexiton, by utilizing molecules that cannot exit the membrane for nano-organs, such a complexiton would gain an evolutionary superiority. To explain, the membrane could have prevented these nano-organs from leaving the complexiton, while allowing the rest of the nano-organs the membrane surrounds to inflict a correcting contingent dimensional feedback on the infected nano-organs. In addition, such a membrane could allow some particles to enter the complexiton it surrounds, and therefore allow the complexiton to replace its particles and retain its kinetic equilibrium. Apparently, by chance, complexitons managed to mutate and sustain such a behavior. Still, we cannot determine the manner by which complexitons learned it. Naturally, we could think of many algorithms, or alternatively, deterministic automatons, which theoretically could yield such a membrane. For example, complexitons could have sustained a behavior which determined that at a specific distance from the location in which the complexiton assimilated the particle, or alternatively, at a specific level of contingent dimensional entropy of its nano-organs would shift to a different state in which they would construct this membrane. However, regardless of how it happened, once complexitons managed to surround themselves with membranes, then obviously, they took over the earthly animal kingdom. Cellular life established itself as the dominant pattern earthly life forms exhibited. Indeed, arguably, some contemporary complexitons, such as viruses for example, exhibit different behavioral patterns. However, being viruses, or alternatively, parasites, viruses are dependent on cellular life forms. Therefore, obviously, viruses are not the dominant pattern earthly life forms exhibit, as they cannot flourish without cellular life forms, while arguably, cellular life forms can flourish without the help of virus-type life forms. However, honestly, we should not concern ourselves with the exact manner by which complexitons evolved into cells. The explanations we provided so far for the formation of life are so ill-founded that arguably, they are not worth the time we invested to provide them. Still, as we previously suggested, the effects of JDS automatically discredit any other explanation we could have provided. Therefore, arguably, there is no reason to try and find additional explanations. Moreover, because cellular life forms are so elementary to the manner by which we perceive life, possibly, we will not find or recognize any evidence for pre-cellular life forms, such as the clouds we mentioned previously. In short, essentially, the explanations we provided are good enough. We have managed to incorporate living cellular life forms into our metaphysical theory, while refraining from breaching the consistency of its foundation, and therefore, we should proceed from this point toward our ultimate goal, meaning the essence of our consciousness. Still, we should refrain from discussing the formation of different components within cells, such as ribosomes, mitochondria, and the likes. The truth is, again, due to the effects of JDS, we simply cannot know how they emerged. Nevertheless, undoubtedly, the introduction of membranes had a profound impact on the manner by which evolution progressed. Indeed, membranes provide a contingent shield for cellular life forms. Moreover, it allowed cells to more easily evolve. To explain, before the appearance of membranes, complexitons could sustain only small variations in the automatons they sustained, beyond which they would have lost their spatial integrity, and therefore, could no longer sustain kinetic equilibriums. However, once complexitons began surrounding themselves with membranes, this was no longer a problem. Just as these membranes provided partial contingent dimensional protection from inbound particles, these membranes forced the nano-organs of these complexitons to stay within the boundaries of the complexiton. Therefore, cellular complexitons had a better chance to assimilate variations in the automaton they sustained, without losing their integrity. To explain, again, while the membrane prohibited the entrance of some particles, obviously, it allowed the entrance of others. Again, without this supply of fresh raw materials, arguably, complexitons cannot maintain a kinetic equilibrium. However, being particles, the particles that manage to penetrate the membranes of cellular complexitons must have spanned their own nano worlds. Therefore, some contingent dimensional transmissions could still affect and mutate the nano worlds governing the automatons these complexitons obeyed. Moreover, with membranes fencing the outskirts of these complexitons could sustain several kinetic equilibriums at once, as their functional integrity could rely on the membrane to ensure the spatial integrity of these complexitons. Still, the introduction of membranes had even more profound implications on the evolution of life. First, membranes allowed a new type of regularities to govern life forms. These regularities did not apply to the internal states of nano-organs. Instead, they applied to the collection of internal states of the nano-organs of which complexitons consisted, as well as the collection of external states, which the antimatter flow inflicted all over the membrane of these cellular life forms. In other words, abstractly, these membranes were analogous to an additional enclosing dimension of life. To explain, just as the dimension of life allows particles to react to external states the antimatter flow inflicts, as well as internal contingent dimensional states, these membrane allowed life forms to determine the functions they performed, according to the external states outside the membrane, and the internal states of the collection of all of the nano-organs the membrane surrounds. Secondly, the introduction of these membranes changed the manner by which complexitons reproduced. To explain, before the introduction of membranes, complexitons could simply emit old nano-organs which repeated the same functionality as their parents. However, with the appearance of membranes, these offspring particles could no longer exit their parents, as the membranes of their parents prevented it. However, obviously, without reproduction, cellular life forms could not have become as dominant as they are today. In fact, arguably, they would not exist at all, as inevitably, all complexitons eventually breach their kinetic equilibriums. Therefore, to persist to exist, cellular life forms revised the reproduction method we know as meiosis. Thirdly, the level of integral security membranes provided for complexitons allowed cellular life forms to be more tolerant to other life forms. To explain, before the emergence of membranes, potentially, any contact with external life forms was deadly. External life forms would repeatedly hijack nano-organs from complexitons, and therefore, inevitably, any tolerance to external life forms would lead to the extinction of such tolerant life forms. However, with the protection of a membrane, this no longer occurred. In fact, the existence of similar life forms side by side enabled an evolutionary advantage, as it allowed life forms to undergo evolutionary refinement. To explain, when cellular life forms reproduce, generally, they remain in the same spatial area of their ancestors. Moreover, because they have common ancestors, similar automatons govern them. Indeed, all these offspring cells can be hostile to one another. However, this is only one option. If the automaton they share allows it, they can tolerate or even help each other, while remaining hostile towards life forms of different ancestry. Essentially, such life forms yield colonies of similar life forms, while preventing the entrance of other life forms into their territory. This in itself provides such life forms with an evolutionary advantage, as the collection of such similar cells, working for a shared general interest, ensures that even if one of these cellular life forms ceases to exist, or alternatively, die, most of its siblings would persist to exist. Therefore, the automaton that governs them would persist to exist as well, and grow ever more dominant. Still, there is more to it. Because these cells do not compete with one another, they might not resist the slight variations, which might occur between sibling cells. Therefore, they provide a supporting evolutionary feedback. To explain, if one of these sibling cells mutated in a manner that reduces its self-sustainability, it would die, while its less decadent brothers will continue to exist and reproduce. However, if a sibling cell mutated in a manner that provided it with an evolutionary superiority, it could have exceeded the survival abilities of its siblings, and therefore could slowly overtake the entire cell colony. In short, contrary to pre-cellular life, the survival ability of cellular life forms increases the more they work together as a community. Indeed, cellular life forms can flourish, even if they are selfish. For example, amoebas, a common single-cellular life form, still exist in our world. However, in itself, the survival of single-cellular life forms does not undermine the evolutionary successfulness of community-oriented cellular behaviors. While selfish, single-cellular life forms must ensure their survival independently, within a community of cells, different cells can perform specific roles for the good of the entire community, while other cells can utilize the resources other cells provided for them to perform roles they could not afford to perform otherwise. Indeed, to work together in a synchronized manner, all of these cells must sustain a similar automaton. However, the cell community can assign different functional segments of this automaton to different cells. For example, while some cells can take the role of transforming inbound materials into usable nutrients, other cells can use these nutrients as energy, while seeking new sources for food. Still, to achieve such complex cellular responsibility distributions, these cellular colonies required a unifying entity to govern the community as a whole. To explain, in order to function as a community, a cellular colony requires an entity to evaluate the collective states of all the cells of which it consists and determine a preferred course of action. To clarify, if we consider our last example, the cellular community must know it suffers an energy shortage, recognize where to find the materials it requires, and then send some cells to attain them. Indeed, this was all the product of evolution. To clarify, cellular colonies did not evolve in this manner because it was beneficial, but rather persisted to exist because the accidental behaviors they attained yielded an evolutionary advantage. Nevertheless, to attain these abilities, these cellular colonies required new capabilities. Simply put, they required the ability to think.